type of rules that we're going to look at is what part of a function indicates a vertical shift. Okay, so you can see here I have f of x plus k plus some constant, or here f of x minus some constant. Okay, when you have a function where something's being added, okay, this represents a shift upward. Okay, and it's going to shift up k units. If you have something that's being subtracted, it represents a shift down k units. Okay. So when you look at something like this here, and again, you're going to be asked to look at this in several different ways. Okay. Tables, possibly coordinates, and then possibly from a graph. Okay. But if you are given this, this table of values right here, if you know that g of x is whatever the output for f is plus 2 at that same corresponding x, then what would be the g of negative 6 for this equation right here? It'd be a shift of plus 2, so 2 more than what the f of x, the original f function, would be, and so that would give you what here? 13. What here? Negative 6 up to what here? Positive 2, and what here? Up 2 from 6, 8. Okay, very simple. The relationship, it's just dealing with vertical shift is the value that's being added or subtracted outside your function. Okay, again, notice how this representation, this notation is represented. We take an entire function and we add 2 to it. Every output value gets shifted up 2 units. Okay, so I want you to fill out this table on the right on your own, given this equation here that g of x is equal to f of x minus 5. Again, you should be able to fill it out very quickly. You don't need to know what the actual function is, what the graph looks like here. All you're doing is we're identifying what this vertical shift means to our output values. All right, so what would be g of negative 10? This output minus 5. The output g of 10. 8 minus 5, or 3. The output of g of 6 is the f function minus 5, so 0 minus 5. And then finally, the output of g of 1 is f of x minus 5, so negative 15. Okay.